Here is an interesting fact. Dear children, sometimes animals swallow unwanted materials. Magnets come handy for veterinary doctors. Some vets use magnets to get back wire and metal from animals' stomach. Magnetic field. The effect of magnet on magnetic substances depends on the strength of the magnet. In this experiment, magnet A attracts the key even from a greater distance. This is because it has greater strength than that of B or C. Thus, magnets exert their own influence over some distance through space and have their own region of influence. Magnet A, magnetic strength greatest among the three. Magnet B, weaker than A but stronger than C. Magnet C, weakest among the three. Dear students, pair up with your friends and observe this. After observation, answer the following question. The three pins A, B, and C are all magnetic materials. Pin C is not attracted towards the magnet. Why? Your options are A. Pin A and B have more strength. B. Pin C is very weak. C. Pins A and B experience the magnetic field, whereas C does not. The correct answer is option C. Pins A and B experience the magnetic field, whereas C does not. So, pins A and B are attracted. Now, let us define magnetic field. The area in which magnetic force is present and magnetic effect is felt is called magnetic field. Dear students, write down this important definition in your book. Dear children, here is an activity. Take a bar magnet and place a thin sheet on it. Sprinkle iron filings on the paper. Observe that the iron filings are arranging themselves in a particular pattern. Magnetic field of a bar magnet is shown like this. Dear children, now you know how magnetic field is mapped. Try this activity all by yourselves and draw magnetic field patterns in your notebook. Now let's look at Oersted experiment. This experiment shows that a magnetic field is set up around the conductor as soon as the current is passed through it. Dear children, here is a project for you. Collect the following information about Oersted from your school library. 1. Nationality. 2. Year of birth and death. 3. Major achievements. Write down all these important points in your book. Dear children, Oersted showed that electricity produces magnetic field. Is the reverse true? That is, can magnetic field produce electric field? This was proved by Faraday. Here is the experiment. Faraday's experiment. Faraday took a cardboard cylinder and wound a copper wire around it. Between the turns, he wound twine thread for insulating purpose. After one layer of copper wire and twine thread, he used calico cloth again as insulation between layers. He continued like this. And after some layers, he connected the ends of it to a galvanometer. When the magnet was moved in and out of the coil, the galvanometer showed deflection, indicating the presence of electric current. When the speed of the magnet was increased, there was more deflection. Then he kept magnet stationary and moved the coil. Again, the galvanometer showed deflection. He kept the magnet at rest in the coil. There was no deflection in the galvanometer. He concluded that
Only when either magnet or the coil is moved, there will be deflection in the galvanometer.
This experiment shows that a magnetic field can be used to produce electricity. We have understood that electricity produces magnetic field by Oersted experiment and magnetic field produces electric field by Faraday's experiment. This means electric and magnetic fields exist with each other. Be sure to try out this. Step 1. Fix two small nails at some distance with each other into a whole lemon. Step 2. Connect these nails with thin insulated copper wire. Dear children, write down all these steps in your book. Step 3. Bring a small magnetic needle near the setup. Step 4. Magnetic needle shows deflection, showing the presence of magnetic field. Try yourself. Write down all these steps in your book. The required materials are two small nails, lemon, insulated copper wire, and magnetic needle. Write down all the required materials in your book. Dear children, remember, magnetic force is the action of force at a distance. The area in which magnetic force is present and the magnetic effect is felt is called magnetic field. Current carrying conductor produces magnetic field around it. Now, write down all these points in your book. Now, let us move on to the concept of waves.